The question states for equimolar aqueous solutions of the following compounds, which one will show the highest freezing point. Equimolar means all of them have the same molality. So we need to know which one has the highest freezing point. So as I told you, delta TF is directly proportional to I. So the higher the number of particles, more will be the delta TF and less will be the freezing point. So higher the number of particles, lesser is the freezing point. Now if we look at option A, in option A, if you ionize option A, then you will get the complex COH2O whole 6, 3 positive plus 3 Cl negative. So total number of particles for option A is 4. For option B, the total number of particles will be 3. Similarly, if you ionize option B also. For option C, the total number of particles is going to be 2, and for option D, the total number of particles is going to be just 1, because on ionizing this, because all of this is present within the coordination pair, you will just have COH2O whole thrice Cl3 positive, and we do not count the H2O as being able to ionize, because how will H2O ionize in H2O? That's not possible, right? So it does not ionize. So there is only one particle. So this one has the highest freezing point because it has the lowest TF, lowest delta TF, lowest I, so highest freezing point. So option D is correct. Now the second question is a numerical type question. In it, it states that 0.2 mole of this complex is dissolved in 500 gram of water, and you need to calculate the depression in freezing point, and Kf is given. So it is saying that we have 0.2 mole in 500 gram of water. And it's giving the Kf as 0.56. So the Kf has units. In this case it's not given, but the Kf has units. It's either in Kelvin or in degree centigrade. So depending on what the units of Kf are, you get your answer. So let's just assume that in this case Kf has units of degree centigrade. Degree centigrade, molar inverse. This is not meter, it's molar. Okay, so we have Kf, and from this information we can find out M, and we know that delta Tf is equal to I into Kf into M, and that is what we need to find. We need to calculate the depression in freezing point. So Kf we have, M we can find, so what will be I? So I will be CONH3 whole 6 Cl3. If you ionize it, you get CONH3 whole 6, 3 positive plus 3 Cl negative. So you can see that there are 4 particles we get, so I will be equal to 4. So let's calculate the molality now. So molality is equal to number of moles of solute divided by mass of solvent in gram into 1000. So that will be equal to 0.2 divided by 500 into 1000. So we can put all of these values into delta TF equation, delta TF will be equal to, you can say this is molar, right? So delta TF is equal to iota I 4 into Kf is 0.56 into 0.2 by 500 into 1000. So from this, if you calculate this entire thing, the delta TF comes out to be 0.896 degree centigrade. So that is your delta TF. The next question is again a numerical type question. So it states that 0.01 mole of cobalt complex is treated with excess of silver nitrate solution and 4.305 gram of silver chloride is precipitated. What is the formula of the complex? So 4.305 gram of silver chloride is precipitated. From this we can calculate what are the number of silver chloride moles precipitated. So number of moles of AgCl is equal to 4.305 gram divided by the molar mass of AgCl, which is 143.5 gram per mole. This is equal to 0.03 mole. So according to this, 0.01 mole of the cobalt complex when treated with AgNO3 precipitates 0.03 mole of AgCl. So applying unitary method, if 0.01 mole precipitates 0.03 mole, then what will 1 mole precipitate? 1 mole of cobalt complex will precipitate 3 moles of AgCl. Now when will 3 moles of AgCl be precipitated? 3 moles of AgCl will only be precipitated if there are 3 chloride ions present outside the coordination pair, because only those are ionizable. If we talk about CO NH3 whole 5 Cl Cl2, if you react this with AgNO3 excess, then how many moles of AgCl are going to be precipitated? 2, right? Because there are only 2 chlorides present outside. So at a maximum, 2 of these chloride ions can ionize and can give a precipitate with AgNO3. So this means there should be 3 chloride ions present outside, so that 3 AgCl we can get 3 AgCl, because that is what we are getting from our answer. That is 3 mole of AgCl should be precipitated by 1 mole of the cobalt complex. So from options A, B, C, D and E, only option C has 3 chloride ions outside the coordination pair. So that means our option C is correct. So these were the applications of Werner's theory. Questions like these majorly come of Werner's theory, the question that we just did, and the questions on the depression in freezing points. So all of this we have covered, and next we move on to other topics.